All right, in general, a system of equations is a collection of two or more equations, each containing one or more variables. Okay, so within a system, we're going to focus on three different types. We'll spend most of our time with one type, but then the other two types will come up on occasion. So the first type that we're going to deal with is if the lines intersect, then the system of equations has one solution given by the point of intersection. This system is said to be consistent, and the equations are independent. Okay, so this is typically what you would expect to see when two lines cross. You expect there to be a single point of intersection of some kind. All right, continuing on, if the lines are parallel, then the system of equations has no solutions because the lines never intersect. Their system is called inconsistent. Okay, so and as the title suggests, we're looking at two parallel lines, and this is what in high school you might have written as no solution. So inconsistent, an inconsistent system is sort of a upper level way to say that there's no solution to that particular system of equations. In other words, I gave you two lines, I asked you where they crossed, they didn't. Whereas I asked you where they crossed, so there was sort of an expectation that they would cross, and we come to find out that it's inconsistent. Why did I ask you if I thought they weren't going to cross? Anyways, a no solution system would be an inconsistent system. And then the third type, if lines are coincident, coincident is, you might be familiar with the word coincidentally. It's where two or more things happen at the same time. So if lines are coincident, meaning there's two lines on top of each other, then the system of equations has infinitely many solutions represented by the totality of points on the line. The system is consistent, and the equations are dependent. Okay, so you have to kind of visualize what I'm saying here. I give you two lines, and I ask you where they cross, and so we would say that they cross, well, they have every point in common. It's not enough at this level to simply say that there are many solutions or infinitely many solutions. We actually will need to clarify what type of lines that we're dealing with. We'll go over the mathematics and what the expectations are on that a little bit later when we actually look at some various examples. There are two main methods that we're going to look at as far as solving systems of equations go. Now, you might have encountered a third method in your previous knowledge, which would be by graphing. Graphing is it's an easy method to use, assuming you remember how to graph, but it's very inaccurate when your solutions are things that involve fractions or decimals. So typically in a college setting, we don't usually show graphing, but it is an option if the numbers are nice and pretty. Under substitution, okay, so the steps is that we're going to pick one of the equations and solve for one of the remaining variables in terms of the other remaining variables, Okay, so looking over at these top two equations here, I've got 2x plus 3y equals negative 3, and I've got 4x minus y equals 3. Is there an equation where I can very easily get one of my variables by itself? And the answer is yes, I can get y by itself in that second equation. So 4x minus y equals 3. I'm going to add y to both sides, and I'm also going to subtract 3 from both sides. And this is an arrow, so I'm going to be very clear on what's about to happen here. So when I do that, I get 4x minus 3 equals y. And so by moving things around, it was pretty easy to get y by itself in that case. So that's what that first step is trying to get you to do. The second step is to substitute the result into the remaining equation. Okay, so in that top equation, I've got 2x plus 3y equals negative 3. And I've got this statement about y. So y happens to equal 4x minus 3. So I'm going to go into that second equation, that equation there, and I'm going to substitute in my y value. And it looks like this. Okay, from here, I'm just going to solve. I'm just going to try to get x by itself and figure out what I have to know, what I have. And that's what step 3 is about, is to simplify the equation from step 2 and solve for the remaining variable. So 2x plus, and I'm going to distribute that in, 12x minus 9 equals negative 3. I see some like terms that I can combine, so 2x and 12x is 14x. I'm going to bring the 9 over, so 14x, let's add 9 to both sides, so 9 minus 3 gives me 6. And then from here, I want to divide by 14. So I get x is 6 over 14, which reduces down to 3/7. All right, next step. Step 4 is to find the remaining value of the remaining variable by doing something called back substitution. Okay, so in back substitution, what I'm going to do is I know what x is. So let me go back to that equation where we had y by itself. That y equals 4x minus 3. And let me substitute in my x value and see what I get for the y value. So 4 times something minus 3. So that would be 3/7. So that's y equals 12/7 minus, and I'm going to rewrite 3 in terms of something that will combine with 7. So I need a fraction that has a denominator of 7, but when I reduce it I get 3, and hopefully you got 21 over 7. So y in this case would be negative 9/7. All right, and that brings us to the last step, which is to check the solution. So just kind of double check, either mentally or mathematically by writing it out, that the solution actually works. So we'll go back up and we'll just pick one. Let's do that. 2x minus 3y equals negative 3. So 2x plus 3y equals negative 3. And we'll just substitute that in. So 2 times 3/7 plus 3 times negative 9 over 7. Does that in fact, question, equal negative 3? Well, let's see what we get. We get 6/7 minus 27/7. And again, not sure if that's right yet or not. That's what we're confirming. Well, 6 minus 27 is negative 21 over 7. And does negative 21 over 7 simplify down to negative 3? You betcha. Okay, so our solution then, so we kind of write this out, would be 3/7 comma negative 9/7. Okay, so the other method, the second method we'll look at is something called elimination. And so in elimination, we're going to start in step 1 by multiplying both sides of one or both equations by a non-zero constant so that the coefficients of one of the variables are additive inverses. Okay, so that's mathematical speak for look at your two equations and is there a number I can multiply one or both by to get a variable to cancel out? So I'm looking at the x's and the y's. I get to make a decision right now which one I want to eliminate. Now I'm looking at the x's and I can very quickly just multiply by a -1 and that would give me opposite numbers that will cancel out x's. Or I could multiply the bottom equation by +3 and that would give me a -3y to cancel out with the +3y. So I get to make a choice and there's no good or bad reason for it. I think the easiest way to do that is just to take that bottom equation, so that 2x minus y equals 3, and just multiply that by -1 to generate -2x plus y equals -3. I think that's probably the easier way to go about doing that. Our second step is to add the equations to eliminate the variable. Solve the resulting equation for the remaining unknown. Okay, so we're going to take that top equation, 2x plus 3y equals -1, and we're going to take the bottom equation that we just wrote, and we are going to add those two equations together. Now, what should happen is, if we did it correctly, one of our variables should go away. And in this case it does. 2x minus 2x, I get 0x. 3y plus y, I get 4y. And then -1 plus -3 gives me -4. So I have 4y equals -4. And I'm going to divide both sides by 4. And so I get that y is equal to -1. Okay, not done yet. Step 3, we're going to back substitute the value of the variable found in step 2 into one of the original equations to find the value of the remaining variable. Okay, so in other words, I know what y equals. Y equals -1. I get to make a decision about which equation I want to mess with. 2x plus 3y equals -1 is fine. So I just get to pick an equation, and then I'm going to substitute in that y value I found and see if I can figure out what x is. So 2x plus 3 times -1 equals -1. So bring that up. Let's see. So 2x minus 3 equals -1. I'm going to add 3 to both sides. So I get 2x equals 2. So if I divide by 2, I get x equals 1. Okay. That brings me to step 4, which is to check the solution found. So I found that x is 1, and I found that y is -1. So to check it, I just need to pick an equation. And since I used the 2x plus 3y equals -1, if I use that one to find the x, I kind of want to pick the other equation and just double check it works in that one. So 2x minus y equals 3. All right, so 2 times 1 minus a -1. All right, not sure if that's right or not, so that's what the question marks mean. Well, what do I notice? I notice a negative and a negative is a positive. So 2 times 1 is 2 plus 1, and that most clearly is 3. So that actually is the right answer. And then last but not least is to write it out as an ordered pair. So let's see. The x value should come first, which is 1, and the y value is -1. Now, just as a little side note, just be careful with the order. Order matters, and when we plot points and we look at solutions, x should come first then y, and it doesn't matter the order we find the number, because again, we get to make decisions about which order we find it in, but universally we want x to be first and then y.